Today we'll be looking at conversions from states of matter. With last Until last class we looked at the different states of matter, the physical and chemical classification of matter. Today we'll be looking at changing the states of matter. So it says freezing. For example, let me take an example of ice. So ice cube is in solid. Then you melt it, you add heat to it, it becomes liquid. Yeah, so melting is from solid to liquid. Then if you evaporate it, it becomes a gas. If you evaporate this water, okay, and if you go the other way, so if you have a gas and then it becomes water, that's called condensation, gas to liquid. Then from liquid to so if you have water and you want to convert it to ice, you freeze it. Yes. Now there's two things called deposition and sublimation. If you directly go from solid to gas, skipping the liquid phase, it is called sublimation. And if you go the other way around, skipping the liquid phase, it's called deposition. You know those naphthalene balls that you have? Uh, so those are solid in state, and they just on room temperature they just convert to heat. Basically, they just convert to water. They just convert to gaseous form. They start releasing chemicals which convert them to gaseous form, and that so you see them. They don't melt, then they form liquid. No, they just directly go from solid to gas. So just seeing this triangle, you can use this for visual learning. Now you can express. Now I'll explain it later when we look at kinetic and particle theory. Why does this happen? But if you look at this graph, this is the heating curve. So this graph is called the heating curve, and the cooling curve is just the opposite. Okay, so if you look at it, you go up solid, so you're adding heat. Yes, at some point it becomes a liquid, and that point where it becomes a liquid is known as a melting point. Then you're not heat is still being passed, but the temperature is not rising, because since it's a liquid, so solid and liquid exist simultaneously here in this latent phase. This is known as the latent phase. So let me just this is known as the latent phase. The one in green is known as the latent phase, and here solid and liquid exist simultaneously. So to completely become liquid, it needs to use the heat that was already supplied here. Okay, then you continue you put in heat, and at one point it becomes vapor, and that is the boiling point. And here it again, liquid and gas exist simultaneously, and then it continues as gas. So this here is melting, this here is evaporation or vaporization. This is known as latent phase of melting, and latent, this is L by the way, this is latent phase of vaporization. You don't need to know the latent phases, like label them, but yeah, just have a look at this diagram and try to understand. Now this is the so when a substance is heated up, its molecules move faster with greater energy, and this results in collisions, causing the substance to move farther from one another, becoming less dense, and therefore changing their state. So, as explained in the last class, if you have a solid and you pass heat through them. The strong intermolecular forces between the particles which hold the particles of a solid together, they start breaking because you're supplying energy. It's an endothermic reaction. Since you're supplying energy, those bonds start breaking. Bond breaking takes place. And there is more. So I will supply heat, for example. This atom, this particle gets the heat, then it passes it on to another particle, and then it goes from one to one particle, and this is known as conduction. It's a physics concept, but it's good to know. This is known as conduction. Okay. Now, in terms of, so they start moving apart, the and then they become liquid. Okay. Now, when they become liquid, if you again supply heat, again those bonds start breaking, and then they become gas. So really, really far apart. Okay, so a substance can be a solid, liquid, or gas. It can be in all three states, and it can change from state to state. Each state will have different characteristics. Each state is different in the way particles are arranged and move. So, if the temperature increases, the average kinetic energy also increases. So I'll just label it as kinetic KE. The average kinetic energy also increases. So basically, there will be a greater number of particles moving, and more collisions will be there between particles, causing them to move apart. Now, and when you start cooling them in an exothermic, when heat is lost, what happens is these forces come together when heat is lost. Okay, think about it in terms like you can remember it as friendship, for example. So if there's a lot of fight going between you and your friend, if there's a lot of heat between you guys will obviously your strong bond that holds you together as a friend will slowly start breaking. But when you resolve all that fight, when it's really cool between you guys start coming together again. So think of it in that way. Now, diffusion, there's another concept called diffusion, and it is when particles flow from an area of more concentration to an area of less concentration. It's not contraction, it's concentration until all the particles are evenly distributed. Say, I have, mm, yeah, say I have four particles here. One, two, three, four. Okay, and it's joined. It does not require a membrane, but for separation, let's say this was the thing that separated it, and you have another one which has three, sorry, which has just two molecules. So area of high concentration to an area of low concentration, hypotonic, area of high concentration, hypertonic, go in this way. Now what happens is you have one, two, three here. Yes, and then you have one, two, and one from there, and it is isotonic now because it's balanced. So it moves along the concentration gradient. So what does the concentration gradient say? High to low, and it does not require energy. Think of it as you on a slide. You're going from higher to lower with gravity is known as, so you don't need energy. So you're going along with gravity, in the direction of gravity. However, if you're going up, which is a biological concept, which is called active transport, you require energy because you're going against the concentration gradient. And you'll see that this is really important in biology and chemistry in some cases, where we have to explain how, for example, let me give you an e-assessment example. Um, Now, nitrogen dioxide is released by fumes and it's a pollutant. but it's only released in one area. Now, how does it spread throughout the atmosphere? Why does it spread? Well, again, because if you apply the concept of diffusion, you will realize that there's more concentration of nitrogen dioxide in that area, and because it does not require a membrane, you can just those nitrogen dioxide molecules will move around. They will basically diffuse. They would diffuse into the surrounding air. They would move from that area to a lower concentration area where there is less nitrogen dioxide. And this was a 4 marker in E assessments. Now, there are certain factors that affect diffusion. Temperature is one. So, an increase in temperature increases the rate of diffusion because there's more kinetic energy, which means there will be more vibrations, which will increase the speed of movement, rate of diffusion. Now, there's concentration difference. A higher concentration difference will result in a faster rate of diffusion, as a lot more diffusion needs to take place. Now there's diffusion distance. The shorter the distance between particles, the faster they will diffuse. For example, if I look at it in a biological concept, our say our small intestines, they have a thin layer, or our cells, they have a thin cell wall. Guess why? Cell membrane. Sorry. The reason is for easier diffusion. Now, mass of the molecule. The more the mass of the molecule has, the rate of diffusion will decrease, as a greater mass means more energy is required to move it. So, if you have a heavy box sliding down a slide, it will take much more time compared to a ball. That was it for today. Those were the processes: kinetic theory, um, the heating curve, the latent phases. This is the latent phase of vaporization, melting, knowing where it is. So in this state indicates that the change of state is taking place when it says this, and here heat is being supplied. Okay, then you have diffusion, and you have factors affecting diffusion. Thank you.